Got a Toshiba SA7150 in for service, and this one here has been in here before a few years back. This time it's in because the radio memory is not working. You save the memories and it reverts back to the original setting. Let's check this one out. Alright, I got the beast up here. For those of you who remember this from the last time I did a video on this one, this is an SA7150 Toshiba receiver. And this is the same one that you saw before. This one has a new problem. He says the radio is not working properly. So let's see what it's doing. AM. I guess that's as high as it goes. Is 1605 is what it's going to. That'll pick up my test transmitter. No problem. Anyway, what he's saying is that when he switches it to FM, it won't maintain any memories. Everything goes back to 1605. You can switch it to FM. Tune the station in. When he turns it off and turns it back on, it's going back to 1605. So he says. Well, that time it remembered it. Let's just try memory. Ah, okay. It's not memory. Okay. Let's see if it maintains it. Ah, see, I just saved it to memory 1 and it did not save. I put it on FM, memory 5, memory 6. When I change the channel, it goes back to 1605. It's not memorizing the station. So what I don't know on this is whether we've got a RAM failure or whether this one's battery backed. I don't remember what this is, but let's just take a look at it and see what this one uses for memory. This one might use static RAM, and the static RAM chip might be shot. Well, let's pull the top off it and take a look. Remove the screws, and the metal cover lifts off first. And then the front cover can also lift off to reveal the rest of the tuning circuits and so forth. So, power amp, big transformer, separate power supplies for each of the output stages on this. This thing's got a lot of power. You know, 150 maybe per channel, 140, 150, I forget. Anyway, we're looking down here at the tuner board here. See if we can figure out why it's not maintaining the memory. It's very likely that there's a static RAM. I don't think this one. Some of these use a capacitor to back up the memory, and others use a static RAM chip. This cap was changed on it years ago. I would have changed that. FMD mod. I think this is the PLL section right here on this. Yeah, this is the PLL. One of these chips is probably the memory chip. Let's look them up. Okay, this is the TC9123. That's be a phase lock loop, that one. Alright, if we look down at the schematic here, the controller is, they call it Q703. TC9124AP. This is the controller. This has got the memory in it. That's the big IC. The other one, this one here, the 9123, that's the phase lock loop. And you can see the crystal. This is the one that stores all the memories. If we look down here, here's our memory switches, right? Up, down, 1, 2, 3, 4, 5, 6. They all go into this IC. This IC stores the memory, and it does have a backup power. I've kind of highlighted it here, but C721, which is the 10 microfarad or 100 microfarad 10 volts, feeds into pin number 28. We should have a backup supply voltage on there. Let's just measure that voltage on pin number 28. This is the IC right down here. It's hard to see because of that camera angle, but I should have on pin number 28, I should have my backup voltage. We'll see whether I'm getting the backup voltage. If I am getting the backup voltage and it's not storing the memory, it's going to be ending up being the controller chip itself has failed. And that is a bad thing because I don't think we'd have a snowball's chance in hell of finding one of those controllers. Now this thing's from 1978, but let's just check voltage and see whether it's got any supply voltage there. Even when it's off, there should be a backup voltage on that that pin. So pin number 28 over here has 6.4 volts. So this should be holding the memory. I'm just going to find a place to put my meter here so it kind of stays hooked up. This should be the backup supply and it should hold voltage. But regardless, it's not storing the memory. Like, I can set a memory live on this thing. I can put it on FM and I can save it to all the memory channels if I want. And will it hold it? Will it hold it? Okay, it's holding it now, but if I turn off the power and turn it back on, will it hold it? It's still holding it. I wonder, it's just losing its power. That might be what's wrong with this. We'll turn it off and we'll see the voltage drop on here. So now the voltage has gone down to 3 volts. And it's reset. Is it reset? It's still holding it. Okay. Let's just see what happens. We might be just losing our backup. That's what the hope is that the voltage is just dropping off on the backup and the memory is being corrupt. So the backup is down at 3.8 volts. I think it probably should be a little bit higher, but who knows. Schematic doesn't actually tell me what the backup's supposed to be. But it's down at 3 volts. And it is holding the memory. It is holding it. Let's see if I change memory here. Oh, no, it's gone. It's gone. It's going to set a bunch of different frequencies on here and see what happens. Okay, it is holding the memory right now. It's off right now and the voltage is holding at 4.5 volts. Turn it on and it goes up to 6.3. I'm just wondering whether the voltage is dropping off and that's why it's losing the memory. Because that would certainly do it if the voltage were to drop off below the point that's required to maintain the frequency memory. I'd say there is a capacitor on here. It's a 100 microfarad at 10 volts and it's C721. Let's just see where that one is. It probably needs to be changed. This is the memory backup. This little gray one here. I'm gonna replace this cap. That one for sure. We'll do that right now. I'll change that cap out because that one there would certainly cause us to lose memory. Problem with the lights reflecting off here on the camera, messing up the auto hour. So let me just change this one here out. I think on this one I might just nip this cap out and just change it without pulling the board. And I say that because I just don't want to put any undue stress on the board and any of the connectors and stuff. This thing being as old as it is, I should be able to nip this cap out and just put another one in here. There's one lead off it there. There. I can get to the leads and just solder a new one right on top of there. It's just a 100 microfarad at 10 volts. We'll pop a new one in and see how that works, how it will store the memory on this one. Okay, I've got a new one. It's 100 at 16, which is more than enough. Just tack this one back down to the existing leads that are sticking through the board. There we go. Easy peasy. This amplifier actually probably would be a candidate for a recap at some point, but the fellow that owns it is deaf in one ear, and he wouldn't notice the difference in the sound quality changing out all the caps on it anyway. So he brought it to me specifically to deal with the memory problem, so that's what we want to resolve. And since he doesn't want to spend a lot of money on this thing, I know that from the previous experience I've had with it. He got this for free. It was given to him years ago, and I've maintained it a few times over the years. So he likes it because of the power it's got, and it sounds pretty good, and it's got a good radio on it, and it weighs a ton, but he won't spend money. So plug it in, check the backup voltage and see what the backup voltage is showing up right now. You can actually measure it right here on the capacitor. Where are we here? I think I have to turn it on first, and then it charges up, because this is what holds the voltage. 6 volts, and this is what holds it when it's off. And this will sit there and hold it at the voltage it needs to sit at. And it'll hold the voltage to hold the memory. I've programmed the memory stations. I've programmed 6 memory stations on AM and FM. Okay, so I'm just going to shut it off, and we'll let it sit for a while and see if it holds the memory. And if it holds those memory channels, then I'm happy that we've solved the problem. And it was just that the memory cap was getting a bit weak and losing its capacity, and then the voltage was dropping off, causing it to lose the memory. If it still loses the memory and the voltage is there, then it's going to be the chip itself. But the fact that it is maintaining the memory, I think it's a pretty safe bet that the chip itself is okay, and it was just losing the voltage. And that's what he said. He went away on holidays. He was away for a while, and it was turned off, and when he came back, he turned it on, and the memory was gone, which would stand to reason that just the cap went bad and the voltage dropped. See, on a unit like this, when the power is off, the power is off. It relies on that capacitor to store the voltage for the memory. And some units would use a battery or a super cap. This one's just using a regular 100 microfarad. It was a 10 volt rated. I've put a 16 in now, which we're good. So I'll let this thing sit for a while and see if it holds the memory. And if it does, then I'm happy. And it's a nice, easy, simple fix for one of these. So you can pull the board out if you want, but just knowing how this thing's got all these connectors on it, I've pulled the board out before to work on it. It's kind of a pain to do it. So if you can clip it out and replace it like that, quick and dirty and quick and fast, and you know it's going to work, and you're not going to put the board under any undue stress, which is what you want to try to avoid doing, is stressing these old circuit boards, because the copper traces on them weren't great to begin with, and they haven't gotten better in the last 45 or so years of use. Alright, the unit's been sitting for a while. It's still holding the FM memories. Excellent. AM. Yeah, it's still holding the AM memories too. So, I think this thing is done. No antenna on here, so I think I can put this one together and send it back. I think we got the problem solved on this one. I noticed that when I turned off the power that the voltage was dropping down to about 4 volts on the backup, which might be a little bit on the low side. Now the backup is supplied from a constant source from power supply H06, which is on the bottom of the unit. Here's a blown up view. So we have our backup supply here. This is what feeds into that circuit to back up the memory. And as you'll see here, it's taken right off of the AC supply. If I can find something to point with, how about a pencil? So we take a direct tap from the unswitched AC. So here's our AC line coming in. This is our neutral side, and this is our hot side. The hot side's coming in. This is going to the power switch here, which feeds the main power transformer. There's a tap taken off of that goes down through. There's a resistor R903, which is looks like 680K maybe, and then R904, another 680K. So there's two 680K resistors, a diode, and then a Zener diode, which says it's 8.2 volts, and C902 and C903, which are two filter capacitors, and then a second diode here. And this gives us our backup power, which obviously is directly connected to the AC mains, but it's going through two relatively high ohm resistors, so we've got still some fairly good isolation. I want to check these components out on this board. It's on the bottom of the unit. I got to pull the bottom off to get to that, and we're going to check that and make sure that that other capacitor here is in good shape. This one and this one here. There's two of them. We'll check those, and of course also check out the Zener diode, but more than likely it's one of the other capacitors that's gone bad. So let me pull the bottom off the unit. So this is the circuit board in question. Here are the resistors. And the 3 diodes, got a Zener diode, 2 diodes and a Zener. Looks like that's been replaced once, doesn't it? These are the 2 capacitors. This one was replaced at some point. At some point this was replaced. It's not original. This one here is definitely an original one. This one's probably bad. We're going to change out this one as well. But let's just check the voltage coming off of this unit. So I've got the unit plugged in. 1.4. Here's our voltage here coming off the We also have 2 680K resistors going between the neutral and the chassis ground. So let's just check those. They'll all be right here. So I'm just going to measure the resistors, the 4 resistors that are in line with the neutral and the hot, which isolate this through. There's 4 680K resistors, 2 of them in series each, 2 here on the neutral side and 2 on the hot side, which really doesn't really matter because it's not a polarized plug. So regardless, either one could be hot. Hot could be going right to the chassis through those resistors, for that matter, because it's a non-polarized plug on this unit. But we have 4 680K ohm resistors, and they are measuring 650, 650, 656. All that, they're all within spec there. I'm going to now remove the little board. We're going to check this capacitor out, because I suspect that this one here also is probably bad. I'm sure that that one's okay. That was replaced at some point, and I probably replaced that years ago for a fault on this unit. Likely before the guy that owns it now owns it, because I've repaired this unit a few times at the shop. It's probably the previous owner that brought it way back in the 80s when this thing would have been fixed. What do you bet this one's gone open? Let's check it with the capacitor meter, and then I'll check it with the ESR meter. So we'll see what the farads are on this one. This is a 1000 microfarad at 10 volts. And this one is measuring 1235, 13. So it's, you know, the capacity measures high, and typically when caps fail, the capacity appears higher due to internal leakage. Let's just see what the ESR meter tells us on this one. So I'll zero it out. Hmm, 0.17. So for a 1000 microfarad, 10 volt, 0.12 would be the maximum that you would want to see. And this one's measuring 0.17, 0.18. So this cap is obviously going bad. We're going to change this one out. I'll check this other little one as well, because there's another one in here in the circuit as well, which is a 10 at 16 volts. So we'll just make sure that this is discharged. We'll just take a look at this one here and see what this one reads. Well, I guess I got to remove it because it's being loaded by other things in the circuit. So we'll just pop this one out. Okay. I was measuring 1.2. So, you know, that's fine, that one. And if I measure it on the other meter, what is it showing for capacity on this one. 10 microfarads, right on the nose. So this one's fine. So we'll put this one back in. I'm going to get a new 1000, and then we'll check that voltage and see if the voltage comes up a bit, because I think it should be a little higher than 4 volts. So it could be being loaded down by something else as well, but that's what the supply voltage is set for, or the Zener is set. Also, it could be the Zener is going bad as well. That also could be limiting the voltage. Okay, so now I've got the new 1000 microfarad cap. We'll check the voltage and see if the voltage has returned to normal. I just have to reattach this ground lug that I took off just so that I could easily move the board around, but we'll leave it detached for the moment. Okay, I've got the unit powered up. Let's just see if the voltage is going to come up. Slowly the voltage is coming up. I would expect it to be a lot higher than that. At 1.3 volts here on this diode. And this one's going to have the standard voltage drop across it. On this side I should have AC, which I do, 41 volts, compared to the other side here, which is grounded. So that's the AC side. So we know that the resistors are working, but I don't have the DC voltage I should have. It could be a diode is bad. Could be this diode here, for that matter. Could be the Zener has gone bad too. Right, so what the second diode does here is this is a blocking diode. So when the main power is on, it stops the voltage coming from the main power supply getting back into the standby. So the second diode is a blocking diode. This is the main rectifier diode here. The main rectifier could be open. It could be the Zener too is also bad. I'm only getting 1.3 volts, although I did have 4 volts before. But I'm seeing at 1.3, and it should be higher than that. The resistors are checking good. So say I got good voltage going in, good power going into it. AC is fine. I'll try a new diode here. If not, then the Zener diode will have to be replaced. So let me just we'll pull the diode and check it and see whether the diode. I can probably measure it right now in circuit because it's not connected to anything. So let's just check the diode out in circuit, and we'll see whether the diode's any good. So 0.5 volt on one direction and the other side is open. It should be more like 0.7. So this diode itself might be going a bit leaky. The Zener itself is also measuring 0.7. This diode here, D901, might be the fault. That should be just a regular run-of-the-mill diode. There's nothing, doesn't look to be anything fancy about that. It's a 1S2462. Let me look that up and see what type of diode that is. And that's just a standard silicon rectifier. So let's just pop that one out. We'll try a new one because I got lots of rectifiers. We'll try a new one and see if that brings the voltage back where I expect it should be. Got the diode out now. So he's measuring a 0.5 volt drop, which looks to be a little bit low. It should be like a 0.7 for a normal silicon diode. I'm just going to replace it with a standard 1N4002, which is a little higher rating, but that's fine. It's just a halfway rectifier, so no big deal. So the voltage is still slowly coming up. I don't know how fast it's supposed to come up, right? Because it's got a couple big resistors on there, but the Zener is probably also bad. So we'll find another Zener diode for that. This is an 8.2 volt Zener. I just happen to have one, which is quite amazing because I don't normally have a lot of different values of Zeners, but I just so happen to have an 8.2. So we'll try that and see if that'll bring my voltage back to where I expect it's supposed to be, which is 8.2 volts. You see, those resistors themselves, they will always be under stress, as will that main rectifier diode, which is one of the reasons I changed it, because the Zener is going to clamp the voltage at 8.2, which means that the diode itself and the resistors are always going to be under some stress. So the Zener shorts or goes bad and starts dropping even more voltage, it's just going to add to the amount of power that needs to be dissipated through both the resistors and the primary diode. Now, if after changing this I still don't get my return voltage, then something else is drawing too much current and loading it down, which is also a possibility, something further back in the circuit. Of course, the new one is a little higher wattage than the original, and the holes are not quite big enough. Here we go. Gotta use my pliers to coax it in. Good enough, it's not gonna touch anything. Okay, let's try the game. We'll see if I get the return of the standby voltage. Okay, so the voltage is still low. So it wasn't those components. It's being drawn down by something else, although it is rising, but it is being drawn down. It's not the standby supply that's at fault. It is being drawn down by something else. This circuit actually appears to be working correctly. It's a very low current charge backup circuit. It's completely disconnected now. The orange wire here ends up at this plug, which connects it to the main board via another connector. If we pull on this wire here, you'll see that this is the wire going to synth. That's the orange wire there. So even with the rest of the circuit disconnected, so this is isolated by itself, like it'll still settle in at around 2.7 volts once it's been charging for a bit. You can see it gradually comes up. This is a very, very low current circuit just for backing it up. Once the unit's been turned on and the capacitors have all charged up, the blocking capacitor, or the blocking diode here, prevents discharge of this capacitor back into the circuit. So it's just very, very low current with these high value resistors isolating the mains from the circuit. So it's like 1.36 mega ohms from each of the mains to either the diode or to ground. So 1.3 mega ohms to ground and 1.3 mega ohms to the diode. If we look at our AC voltage here, we will see that our AC voltage is 42 volts. That's just through the droppers. And DC wise, with respect to ground, it's now come up to 4.7. It's been sitting for a few minutes. I think the circuit's operating because it's disconnected from the rest of the unit itself. If I plug it in, it'll probably drop the voltage down because it's going to charge some other circuits. But you see, so it's going to hover around 3.94 volts. We'll just let it charge up. I think this circuit's operating normal. I don't see any issues with the circuit. When the unit's turned on, course, now it's going to charge up, and it'll now sit at the full voltage, right? It'll actually, if I put it on, it's now getting its power from the main power supply. We turn it off, it's going to drop down, and it's going to sit at the power supply, at this power supply voltage, which when I was testing it, when I left it turned off there for a while, it stayed at around 4 volts. So I think the circuit's normal. So we'll leave the new cap in here. But I think this unit is good to go as it sits. Anyway, that's all there is for this one. I think we got it, problem solved, and we've gone through and double checked everything in the backup supply as well. So I'm gonna throw this one back together and send it back home, and the owner can enjoy it for many more years of use. That's if I don't blow things up putting it back together. Alright, thanks for watching. We'll catch you in the next one.